very similar to that. So, pause my recording. Okay, I do want to jump down to composite volcanoes. Composite volcanoes are very steep and extremely explosive, and that's because they are usually made out of rhyolitic. Rhyolitic magma. Okay, what do you know about the silica content of rhyolitic? Very high in silica, which means therefore the viscosity is also high. So it doesn't really move very easily. It plugs up very quickly. Okay? It's like trying to take a straw and trying to suck up the molasses or very heavy syrup from a straw. It's just not going to work well. So, when you think about this, what really happens with the silica content is you can see how thin this neck is, or the vent. So with that being so thick, so viscous, it literally starts to pool, and you actually get a little bit of a blockage in here, and then that prevents the rest of the magma from going, so you get built up of pressure, you get gases that build up, and all of a sudden you get a major eruption that releases out all of those gases, releases out all that pressure in the magma, and so this is very, very severe types of eruptions. Okay, this is not something that you want to be standing next to when it goes.
Mount St. Helens.
Okay, Mount St. Helens is a perfect example of that. We've had other ones in our area. How many of you guys have heard of Montserrat? Guys heard of that? Okay. That is a Caribbean island. And because of the eruption from Montserrat with its pyroclastic flows, it has literally created a modern day Pompeii. Now, what is Pompeii? What makes Pompeii so special? Oh, come on, guys. Are you serious? Nobody can tell me what Pompeii is. Yeah. What happened there in Greece? Actually, it was in Italy. Yeah, so the pyroclastic flow comes out, all the ash. What did it do to the city? Kill all the people. In fact, if you go there today, you can see the shell, the rock shell, from the pyroclastic flow of these people in their final resting place. No, I have not. So it's actually really kind of cool. I would hate to be them, but this is Montserrat is a perfect example of that. I believe they erupted in the mid-90s.
So you're saying that the lava flowed in...
Not lava. Pyroclastic flows. Pyro meaning what? Pyroclastic. Remember we talked about plastic sediments? Small pieces, very, very fine pieces, okay? What a pyroclastic flow is, take a look at this cloud right here. See the cloud, the ash cloud? Okay.
Does the pyroclastic flow have to do with a composite volcano?
Yes, it has everything. You will find the composite volcanoes have that uniqueness. They're the ones that create pyroclastic flows. Okay? And what it is literally, as long as stuff is coming out, it's forcing that stuff upward. As long as you have an upward force, life is good. But then eventually you lose that explosive power, and what happens? It starts to come back down. That's when you're in trouble. Because as soon as that ash cloud starts descending from the atmosphere, it's traveling at over 300 miles per hour at temperatures over 1,000 degrees. You will not outrun this. It literally burns you from the inside out. The ash that is inside the ash cloud, as you're breathing this in, you're literally torching your lungs, you're burning your mouth, your esophagus. Every time you take a breath, you're literally burning yourself from the inside out. The ash mixes with the natural waters within your body, within your saliva, within your lungs. It's mud. And you literally cement. Not only are you now burning yourself, but every breath you take with that dust, it's creating a mud mixture, a clay mixture inside your body. It's not a fun death. And it will take several minutes for you to die.
So it's not like this.
No, you will be very aware of what you're doing to yourself. And there's nothing you can do about it.
Like fully submerge yourself in the body.
It's just not fun. It's not something to play around with. It's not something to take as a joke. In fact, when we look at volcanic eruptions, most people are killed by the pyroclastic flows than the actual volcano. So it's something to take very serious. I am going to go ahead and model with you guys here.
Can I ask you, so you are explaining pyroclastic flows
Yes.
as what they're breathing in and the air and everything that's spewing out
Yep.
is in the air and they're breathing in.
Yep.
What's the other one? How do you spell that? Is that Montesitic?
Oh, no, Montserrat. That's basically a volcano. They erupted in the Caribbean.
That's it.
Montserrat. Last volcano we need to talk about are the cinder cones. Guys, these are extremely small.
As in comparison to like small for volcanoes.
Small for volcanoes. Having been to Sunset Crater, you're really looking at a volcano that's probably about maybe 1,000 feet tall. So not very large. So again, this is all relative terms. And basically what it is, we do have steep sides, but we had very, very minute eruptions. Okay. How many guys during 4th of July had those cones that had the little showers, right? They spew out the sparks. Okay, that's a great example of what a cinder cone does. It's very small. It's nice, wonderful show to watch, and then it's over.
Yeah.
Okay. Now you guys did mention that you saw that we had a lot of sediments that surround the volcano, and that's because when this erupts, it doesn't erupt with large blocks of rock. It doesn't erupt as smooth rock. It literally is blowing out dust, one thing like that. So it literally just kind of spews its insides and then goes back dormant. Okay, so these things erupt very rarely, but they're kind of cool to watch. So,
Can you relate coal to cinder?
I would say, yeah, I think you could say that because coal makes a lot of coal dust, and when it does burn, typically it burns in that sense. I think probably the best way to envision it would be those fireworks. You know, that just kind of spew out the sparks, and then you're done. In fact, if you've ever actually gone out there after the fireworks are over, you'll see a lot of dust right at the base of the volcano, or the cone. You'll see the same thing with this volcano. Okay, we're actually going to take a lot of stuff, and I'm almost going to completely bury this volcano after the eruption. So our volcano is not very large, but I'm going to completely bury it with using ammonium dichromate. So you can see I didn't really put in that much of the material. It's nice and orange.
What'd you say that is?
Ammonium dichromate. Okay. So I'm going to go ahead and finish this off here with their notes.